As you possibly know, stick diagrams are easy representation of circuit layout, so it's easily you can see how the layouts to be generated. So for a given circuit, what we have to do is start drawing a blue line for VDD and ground. Then we are going to use yellow line for a P diffusion and a green line for a NMOS diffusion. And we will cross red line over these colors to create PMOS and NMOS. Then PMOS sources always go to VDD and NMOS sources goes to ground. So when we wanted to connect, we use an X or a circle. Again, we're not worrying about the contacts. So we will start with the inverter example. So we start with a blue line and label as VDD and ground. And then we need to draw the diffusion. This is the P plus diffusion. And then we have the green one for the NMOS diffusion. Since I only have one transistor on each side, I just have one red line. So this would be my poly, and I would call this one source, that one drain, because drains will be close to the output. Then I have the same thing here. Then I need to use the axis to connect to VDD and ground. And then this one goes to the ground. Finally, I'm forming the output, so I just have this axis and then call this the V out. So this is the simple inverter. Now let's do a 2 input NOR gate, and this is VDD, this is ground. Then we just have to put the active areas, and the top one is always PMOS. Now I have to use 2 red lines. I'm just gonna draw it and not worry about the terminals. I just need to draw this again. Now I can call, now I need to look at the series stack, and it's on the PMOS, so I can just easily call it SD. So I'm done with the series stack. Now as far as the NMOS, I'm not gonna be very quick naming it. So what I can have is call this the source. Now I need to put these in parallel. The only way to do it is to have drains together, sources together. So I will call this the drains and just put an X here and move it to the output. So I can just put a contact and then form the output from the drains. Now I also need here another one. This is my out. Now the remaining terminal is source, and all sources has to go to the ground. So I just now put these 2 transistors in parallel, and I'm completed this thing. When you're figuring out the function for a given stick diagram, I would suggest look at the PMOS stack, the series stack, and just you can actually see the series stack is here. So I can expect 2 PMOSs in series, meaning on the NMOS side there has to be 2 in parallel. You can also look from here and figure out, but it's easy to first look at the series stack and figure this out. So it's a 2 input NOR gate. Now let's look at this 2-input NAND gate. And again, it's the same procedure. VDD, ground, putting the diffusion. And then there has to be 2 polys because there are 2 transistors. Now I have the series stack on the NMOS side, so I just call this SD, right? And then I can just actually be done with it. All I have to do is just put this to ground, and then drain goes to the output. So we're done with the NMOS very quickly. Now for the PMOS, to be able to put in series, my initial point is always with the source. So then I put these drains together and source over there. What I have to do is simply carry the drains to the output, and sources simply go to the VDD. So you're done with the PMOS, the 2-input NAND representation. Now what if it's a 3-input NAND gate? There has to be 3 polys crossing over the active area. And I can just do that at the very beginning. And I can just get rid of the series part. So I got the NMOS side looking like this. And I can just tie this to ground, and these are in series, and then drain just taken to the output. So that's my output. Now we start with the source again, and I call it drain, so I'm gonna put these 2 in parallel. Now once we have this 2 as in the previous example, now here you got no option but put the sources together, right? So you cannot have drain here. Of the last one, it needs to be source, so these are in this is also in parallel with 2. Now all I have to do is take the drains and route to the output, and then here I have a contact, take it to VDD. So I'm finally done with the representation of a 3-input NAND gate. So you can easily see these 2 are in parallel, and that's also in parallel with the 2. Now there is a 4-input NOR gate. And then we got 4 polys crossing over these transistors. And I take care of the series stack very quickly. It's on the PMOS side, as you can see. Source drain, source drain, source drain, source drain. This one going to VDD, this one going to the Y, the function Y. Now I have to start with the source, then this has to be drain and drain, and the remaining is source. Now this needs to be same, and then I got drain, drain, and source. Again, you got 2 in parallel, another 2 in parallel. Now I know that these going to the ground, the sources, and then drains are taken to the output Y. Now you got the representation of a 4-input NOR gate. And again, once you're asked the question, what is the function, you can just refer to the series stack. In this case, it's a PMOS So you know what you're expecting on the NMOS side, which would be 4 NMOSes in parallel. So this is obviously gonna be the 4 input NOR gate. And this is the one we're needing the stick diagram for. And this is the one that how the terminal should look like. As you can see, outputs will always form from the drains. Now let's see how we can draw this thing. There's gotta be 4 transistors. So I have the 4 poly lines. So once I have these active areas, then I can just put that poly. So it's like creating 4 transistors here, 4 transistors there. And probably you can start with this part, which has the most serious stack. I think I'm seeing source drain, source drain, source drain. Now I got this in parallel, so that needs to be drain and source. This can easily be hooked up. Now this is going to be the output F. And then here is a bit complicated, but I know that I have to put 3 in parallel. So SD, DS, SD. Now looking like once I get sources connected, the drains are to be connected together, but it's not gonna go here, rather it's gonna go to this transistor, which will then be connected to the output. So let's see what we're doing here. Source drain, 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 source. So now I got form the drains, which is going to the source, and then this one actually is the one going to the output. So this actually concludes the last example that you're seeing. And this is actually the same circuit. It's just drawn a little different. So to find the function of this thing, it's probably easier to look at this place where you got 3 in series. And then you're seeing that is in parallel with this. And by the way, we forgot to put these inputs on the polys, but normally you should put them in on top of them. And then you just do the opposite for the NMOS side and you can figure out what the function is.